Hi everyone, this video is about arithmetic sequence focusing on finding the value of n. So the value of n here are the position of a term and the total number of terms of an arithmetic sequence. Okay, we know that the nth term of an arithmetic sequence a sub 1, a sub 2, a sub 3, a sub 4, and so on until a sub n is a sub n equals a sub 1 plus quantity n minus 1 times d, where a sub n is the nth term, n is the term number or the position of a term, and d is the common difference, and a sub 1 is the first term. Okay, so let us derive the formula in finding n using the nth term. Okay, the objective here is we need to isolate the value or the n on one side of the equation. So let's start with dividing both sides by d. So that gives us a sub n minus 1. So after dividing both sides by d, we subtract a sub 1 to both sides. That gives us a sub n minus a sub 1 all over d equals a sub 1 plus n minus 1 minus a sub 1. So a sub 1 minus a sub 1 is equal to 0. So that leaves us n minus 1 on this side of the equation. And then to remove negative 1 or minus 1 on this side, we add 1 on both sides of the equation. So we have negative 1 minus or plus 1 is 0. Therefore, a sub n minus a sub 1 over d plus 1 is equal to n. By symmetric property of equality, we have n is equal to a sub n minus a sub 1 all over d plus 1, where n is the position of a term or term number, then a sub n is the nth term or the last term in the given, and then a sub 1 is the first term, d is the common difference. So let us answer example number 1. In the arithmetic sequence 1, 6, 11, 16, and so on, which term is 211? So what term number is 211? What is its position? So let us identify the given. A sub 1 is 1. D, by subtracting consecutive terms backwards, D is 5. The S sub n, or A sub n rather, is 211. What is n? So by applying the formula in finding n, that is n equals a sub n minus a sub 1 all over d plus 1. So 211 minus 1. 211 is the last term here, but we don't know what is its position. So that's we are solving here. All over 5, that's the common difference, plus 1. Performing the operations, we have 210 over 5 plus 1. So 200 over 5 is 42, plus 1 is 43. So n is 43. This means that 211 is the 43rd term in the arithmetic sequence. Okay. Number 2. In the arithmetic sequence 35, 30, 35, 20, and so on, which term is 0? So what's the position of 0? The given are, first term is 35, D is negative 5, and A sub n is 0. What is n? Using the n formula, n equals A sub n minus A sub 1 over D plus 1. A sub n here is the last term, which is 0, and the first term is 35, and D is negative 5. Performing the operation, we have 0 minus 35 is negative 35 over negative 5. And negative divided by negative is positive. So 35 divided by 5 is 7 plus 1, n is 8. Therefore, 0 is the 8th term of the arithmetic sequence. Number 3. Which term of the arithmetic sequence, negative 2, negative 5, negative 8, negative 11, and so on, is negative 32? Again, what's the term number of negative 32? Or what is its position? The given are, A sub 1 is negative 2, D is negative 3, A sub n is 32 or negative 32 rather. What is n? Formula for n is A sub n minus A sub 1 over D plus 1, where A sub n is negative 32, A sub 1 is negative 2, and D is negative 13. Perform the operations. Negative 32 minus negative 2 is negative 30 over negative 3 plus 1, which is 10 plus 1. N is 11. Thus, negative 32 is the 11th term. Number 4. Verify if 79 is a term of the arithmetic sequence negative 1, 3, 7, 11, and so on. The given are, A sub 1 is negative 11 or negative 1, D is 4, A sub n is 79. Okay, let's find the value of n. by applying the n formula, a sub n minus a sub 1 over d plus 1, where a sub n is 79, a sub 1 is negative 1, d is 4. Performing the operation, 79 minus negative 1 is 80 over 4. And that is 20 plus 1. So n is 21. Therefore, 79 is the 21st term. Number 5. Verify if 211 thirds is a term of the arithmetic sequence 1 third, 7 thirds, 13 thirds, 19 thirds, and so on. Given are a sub 1 is 1 third, d is 2, a sub n is 211 over 3, or 211 thirds. What is n? N is a sub n minus a sub 1 all over d plus 1. Substituting the given, a sub n is 213 over 3, a sub 1 is 1 thirds, d is 2. Performing the operation, so subtracting similar fractions, just subtract the numerators, copy the common denominator. So 211 minus 1 is 210 over 3, all over 2 plus 1. We have 210 over 3 is 70 over 2 plus 1. So we have 70 divided by 2 is 35 plus 1. So n is 36. Thus, 213 or 211 rather over 3 is the 36th term. Example number 6. How many 3-digit numbers are divisible by 4? Okay. Given. So the first 3-digit number that is divisible by 4 is 100. And the last 3-digit number that is divisible by 4 is 996. Therefore, a sub 1 is 100. D is 4 because it's divisible by 4. And then a sub n is 996. Using the n formula, substituting the given, a sub n is 996, a sub 1 is 100, d is 4. Performing the operation, 896 from 996 minus 100 divided by 4 is 224 plus 1. N is 225. Hence, there are 225 3-digit numbers that are divisible by 4. Number 7. How many numbers between 25 and 300 are multiples of 6? When you say multiples of 6, they are also divisible by 4. So given So that's between 25 and 300. The first number is 30, because 30 divided by 6 is 5. And then the last number is before 300 is 294. First term is 30, D is 6, because multiples of 6. A sub n equals 294. What is n? So we are looking for the total number of multiples of 6 between 25 and 300. So using the n formula, substituting the given, then performing the operation. 294 minus 30 is 264. Divided by 6 is 44. Plus 1 is 45. Hence, there are 45 terms between 25 and 300 that are multiples of 6. Okay, that's it. So I hope you've learned something from this. Bye.